Unit 4A, Lesson 5. In this lesson, we're going to talk about polynomials, what they are, how to name polynomials, and then operations between polynomials. First, we're going to discuss what a polynomial is. So we have this basic expression to model the general polynomial form. I'm sure this is confusing. A sub n sub 1, a sub 2, all the way to a sub 0. Those just represent coefficients and constants throughout the problem. Then we have x raised to the n power all the way through until we get to x to the first power. That just represents we have a variable x raised to some exponent power. So some properties that are going to be true about polynomials, it's an expression containing coefficients and variables. Two main or key parts to a polynomial must have whole number exponents on the variable, and there must be real number coefficients. Now we'll go through a couple examples and non-examples for polynomials. First, the examples. If we had x to the 7th minus 130x squared plus 1, all the numbers, we have a coefficient of 1, negative 130, and a positive 1. Those are real numbers. If we look at the exponents, 7 and 2, those are whole numbers, satisfies those two main conditions. If we look at the next one, we have radical 103, x to the 9th, minus radical 17. The square root of 103 and the square root of 17, those are irrational numbers, but they're still real numbers. So we have real number coefficients, and then we have x to the 9th power. 9 is a whole number, so it still satisfies those two conditions. Now we're going to look at some non-examples. We have 1 divided by x squared plus 5x plus 4. So if we look at the expression in the denominator, we have coefficients of 1, 5, and 4. Those are real numbers. Our exponent powers, we have 2. There's understood to be a 1 here on the x, so those are whole numbers. The issue is that technically this is going to be raised to the first power. I want to move that to the numerator, so using exponent properties, if we move this to the numerator, it would become x squared plus 5x plus 4 raised to the negative 1 power. So technically we do not have whole number exponents because we have these variables occurring in the denominator. Now we go to the second example. We have 13x to the negative 1 plus 15x cubed. Coefficients of 13 and 15, those are real numbers. The issue here is we have negative 1 as an exponent. That is not a whole number. Now we're going to talk about naming polynomials. So we're going to name it by the degree, which is referring to the highest exponent power on a variable, and then also by the number of terms. So if the degree is 0, we call it a constant. If the degree is 1, it's linear, functions we've talked about in the past. Degree 2, quadratic, functions we've talked about in the past. 3 is going to be cubic. Degree 4 is quartic. Degree 5 is quintic. Now we go to the number of terms. If there's one term, it's a monomial. 2 terms, binomial. 3 terms, trinomial. If there's 4 or more terms, then we're just going to say it's a polynomial with however many terms there are. In this example, we want to name the polynomial by the degree and the number of terms. So looking at the degree, we're talking about the highest exponent on a variable, which in this case is 3. So if the degree is 3, it's a cubic. We look at the number of terms. We have 1, 2 terms, so it's going to be a cubic binomial. This example, we want to name the polynomial 9x to the 4th plus 13x squared minus 2. So we look at the highest degree on a variable, and this one it's 4. So it is a quartic. We look at the number of terms, 1, 2, 3, trinomial. So this would be a quartic trinomial. To end this lesson, we're going to talk about operations on polynomials. In the standard, it uses the terminology, understand that polynomials form a system analogous to the integers, namely, they are closed under the operations of addition, subtraction, and multiplication. Essentially, what this is saying, if you add, subtract, or multiply two or more polynomials, the result will be a polynomial, just like the integers. If you add, subtract, or multiply two or more integers together, the result is still going to be an integer. Perform the indicated operation on the polynomials. In this one, we have addition. We have 2x squared plus 3x plus 1 plus 5x squared minus 4x plus 2. Since we're adding, we really don't need these parentheses indicating the polynomials. Okay, so we can get rid of those right away. How we're going to add these two polynomials together is by combining like terms. Like terms are going to be terms that have a variable raised to the same power. So I see I have a 2x squared and a 5x squared. Both of those have a variable raised to the same power. They are like terms. There's a 3x and a negative 4x, same idea. And then we also have a constant and a constant. So we just have to combine any like terms together, and that will be the simplified form. So adding 2x squared plus 5x squared, combine those coefficients, we get 7x squared. 3x plus a negative 4x, or 3x minus 4x, is negative 1x. 1 plus 2, we get 3. So 7x squared minus x plus 3 is the simplified form when we add these two polynomials together. Using the same two polynomials, now we're going to subtract. So with subtraction, we have to make sure that this negative gets applied to every term in the polynomial that follows. Once we distribute that negative, we can get rid of parentheses. So we're subtracting a 5x squared. We're subtracting a negative 4x. If you're subtracting a negative, it becomes a positive, and that's subtracting 2. Now, just like the last one, we combine like terms, and that will be the simplified form. After combining like terms, you get negative 3x squared plus 7x minus 1. The last example is going to be the one that takes the most work, multiplying two polynomials together. So we're going to take our first term, 2x squared. We have to multiply that through to each term in the other polynomial. Okay? Then the same thing with 3x. We have to take 3x, multiply that through to each term in the polynomial. And then the same thing with 1. We're going to take 1 and multiply that through to each term in that last polynomial. So once you multiply through, you should get the following terms. If we take 2x squared times 5x squared, 2 times 5 is 10. And then if we're multiplying, we have the same base x. So x squared times x squared, the bases are the same. We add the exponents together. 2 plus 2 gets us 4. 2x squared times negative 4x, negative 8x cubed, and then 2x squared times 2 is a positive 4x squared. Go through the same process, multiply 3x through, and then multiply 1 through. Now it's the same type of problem we had previously. Combine any like terms together, and that will be the simplified form. So we only have one x to the fourth term, so we have 2x to the fourth. We have two x cubed terms, so negative 8 plus 15 would get us a positive 7x cubed. Then we have a 4x squared minus 12x squared, negative 8x squared. Negative 8x squared plus 5x squared is going to leave us with negative 3x squared. So cancel out those terms. Then we have a 6x minus a 4x, which leaves us with a 2x, and then a plus 2 at the end. So this is the simplified form for this polynomial when we multiply those two polynomials together. A few terms you need to make sure you understand. Like terms, which simply means terms with the same degree, because that's how we combine them. Addition and subtraction, we have to combine like terms. And then standard form. We talked about standard form for quadratic equations, y equals ax squared plus bx plus c. When we talk about standard form for polynomials, it simply means writing the terms from highest degree to lowest degree. So we'd have an x x cubed, then an x squared, then an x, then a constant. If you write it in standard form, it makes combining like terms and the multiplying process a little bit easier.